Welcome to solverfy.
Question 77 gives us some physical properties of halogenated liquids, and it wants us to explain the following, which one following statements best explains the data. So the data basically shows that as we go from CH2F2 to CH2Cl2 to CH2Br2, basically moving down the periodic table with our halogens, the normal boiling point is going from negative 52 degrees Celsius to 40 degrees Celsius to 97 degrees Celsius. So we are increasing in boiling point as we are moving down the periodic table with our halogens. So let's go to the questions. The first one says the larger the dipole moment, the stronger the intermolecular force. Therefore, the boiling point is lowest for the molecule with the largest dipole moment. Okay, so let's dissect that a little bit. The first half of this is true, that the larger the dipole moment, you're probably, if you have a large dipole moment, that's going to lead to stronger dipole-dipole forces. But the second part doesn't make sense. The stronger your intermolecular force is should lead to higher boiling points. And because fluorine is our highest electronegativity, it should have the biggest dipole moment. Therefore, it should have the highest boiling point, but it does not. So this one, again, it should lead to strong dipole moments, means strong dipole forces, should mean higher boiling point, not lower boiling point. So this one is not an explanation for our data. B, the dispersion forces increase from F to Cl to Br. Since the boiling points also increase in this order, the dispersion forces must play a far greater contribution to the molecular interaction than the dipole-dipole interaction. So the dispersion forces do indeed increase as we go down here because our molecular weights are getting larger, meaning our electron clouds are getting larger, meaning they're becoming more polarizable. And as become more polarizable, we increase the strength of our London dispersion forces. However, that goes opposite the strength of the dipole-dipole. So I would agree with this statement. The statement seems to be correct that in fact it's not the dipole-dipole forces that are playing the biggest role here, is the London dispersion forces, because as we go down this group, we are increasing the molecular weight and therefore we are increasing the polarizability. Or as they say, they were increasing the strength of the London dispersion forces, and as we increase the strength of the London dispersion forces, we are indeed increasing the boiling point. So this one does explain our data. But let's continue. C, the trend in electronegativity. So fluorine has the highest electronegativity, then chlorine, then bromine. Therefore, the most ionic compound, this one, has the lowest boiling point, and that is not correct because the more ionic it is, technically, ionic bonds are going to have a much higher boiling point, right? If you think about trying to boil table salt, so the more ionic bonds should have the higher boiling point, not the lower boiling point. So this one is not an explanation for our data. Finally, in D, boiling points increases as molecular weight increases for these nonpolar molecules. It is true that the boiling point is increasing as the molecular weight is increasing. However, the second part of that is not true. These are not nonpolar molecules. If you see the other part, they all have dipole moments. Therefore, they are all polar. So yes, it is increasing, the boiling point is increasing as the molecular weight increases, but the other part of the statement that they are nonpolar liquids, or compounds, sorry, does not hold true.